Hello, this is page 4 of the SBAC review for Mercer Middle School. If you have Miss Allen, Miss Agopov, Mr. BR, or Mr. Dixon. So if you haven't watched the first 3 videos of the first 3 pages, you can go back and find those. They're also titled the same. Math8 SBA Page 1, Page 2, Page 3, so on and so forth. So this standard isn't labeled here, but this is about using systems of equations to find solutions. So Alexander's heater broke during the coldest part of the year. Here are the costs for 3 companies. Company A charges $15 per hour of work. Now it doesn't say there's any extra cost, so it must have had a 0 starting cost, so they had no fee for starting the work. So my equation would be y equals $15 times the number of hours they work, plus there's 0 starting cost. Company B charges $5 per hour of work and a one-time fee of $20. Y equals $5 times the number of hours they worked, plus they started with a fee of $20. So that's a one-time fee or a y-intercept. Company C charges a one-time fee of $5 and then $10 per hour of work. Notice they changed the order on you here, so really be careful of that. One-time fee means there is y equals blank x plus 5, and the blank would be the cost per hour, which is the second part of the sentence, $10 per hour of work. So we have 3 equations there. Down here it asks us to figure out what's going to happen if I have a job that takes 2 hours, which company should I choose? So we could solve this by putting in 2 hours into each of these equations and figure out this company would be 15 times 2, so company A would be $30, 5 times 2 is 10, plus 20 is $30. And then 10 times 2 is $20 plus 5 is $25. So that is one way of solving this, but they want you to graph it because that's part of the standard. So we are going to draw a graph here. We're going to start with company A. I'll use red for company A. So company A here has a one-time fee of $0, no starting cost, and then $15 per hour. Be really careful to look at your x-axis, which is your number of hours worked. And then be really careful when you're looking at your y-axis for cost, total cost. Because notice these are counting by ones, yes, but it skips. This is not 1, 2, 3, 4. It's 1, so this must be half an hour in the middle, 15 minutes here, and 45 minutes here. So I'm going to go up $15, and this is 20, so that must be counting by 5, 10, 15, 20. So $15 per hour, 5, 10, $15 over 1 hour. Another hour would be 5, 10, $15 over another hour. Another way you could do that would be $15 times 3 hours would be $45. So you could just multiply every charge per hour by the number of hours on the x-axis. So 4 hours times $15 would be 60, plus 0 is 60, so I'm going to keep going like that. This would be, I'll try the other method, 5, 10, $15 for 1 hour, 5, 10, $15 for 1 hour. It's also good, I find, to check using both methods to make sure you're not miscounting. So for example, 6 times 15 is 90, and this would be 80, 85, 90. So that is making sense. Now I'm going to connect my line because I can find out half an hour, how much that would cost, a quarter of an hour, even 10 minutes by making a line and finding all the points in between. So let's connect these points with a straight line. All right, that is company A. Company B, we'll do that one in purple. Actually, just use blue. So company B charges $5 per hour of work, but they have a one-time fee of $20. So they have a higher starting value. For 0 hours of work, they're still charging you $20 just for showing up, but they don't charge much per hour. So $5 for 1 hour. I'm going to go up another $5 for 1 hour. Notice they share a point right here. $5 in an hour, $5 for an hour, whoops. $5 for an hour, $5 for an hour. So notice the line is not as steep. They charge less per hour, so they have a lower slope, but they have a higher starting cost. So it starts out more expensive for company B, but once you hit 2 hours and above, anything more than 2 hours, is costing less for the job. So that's good to keep in mind. We're going to choose what company to pick based off how many hours our job is going to be. Company C, let's do that one in, I don't know, let's use green. Is that a different enough color? No, let's use a different color. Let's go with dark purple. Company C has a one-time fee of $5 and $10 per hour. So $5 is a one-time fee, a starting cost right there. $10, so $10 for 1 hour. Notice I already see my 1 hour is the same cost here. $5, $10 for an hour. $5, $10 for 1 hour. $5, $10 for 1 hour. $5, $10 for 1 hour. And just so I make sure I'm right, let's do this one by multiplying by 6 and adding the extra 5. 6 times 10 is 60, plus 5 is 65. So for 6 hours, it should be 65. And that also matches with going up $5, $10 for 1 hour. So we're good to go. I'm going to draw my line. And we see that we have all the different costs for all the different number of hours. So now we're going to look for a place where they cost the same. So for example, let's also label A, B, and C here so we can keep track. Company A was the red one. This was company A here. Company B was this purple, company B is the green one, or the bluish one. And company C is this purple one. So when we're talking about each of the companies, you can keep track by looking at what we've labeled here. So we're going to look at company C and company A cost the same amount at 1 hour. Company B and A cost the same amount at 2 hours. And company C and B cost the same amount at 3 hours. Now the best company to pick if you're doing 6 hours of work would be company B. It has the lowest cost. But if we go back to a less number of hours, look at that. At the very beginning, B is the worst company to pick for 0 hours for 1 hour. But by the time you get to 6 hours, actually it's the best company to pick. So this is a good real-life situation you could think about. If you're trying to hire a company, it might seem pretty expensive at first because they might have a fee they charge. But if you want a big job that takes a lot of hours, you're going to want to pick the company that charges less per hour, not the company that has the smallest one-time fee. The question here, it says the job will take 2 hours. So we're going to look right here at 2 hours and figure out which is the lowest cost. So I see that company C has a cost of $25 and company A and B both have a cost of $30. So company A is the best cost. No, I'm sorry, company C is the best cost because it is the lowest price. And let's figure out what that price would be. 2 hours for company C is one line above 20, and this is counting by 5, so that's $25. 2, 25, and these two are the same price. Those two are 2 hours for $30. Which company should Alexander choose? I'm going to be really careful. I keep mislabeling these when I say it out loud. Purple is company C. Company C. There you go. So the work I showed as well shows my thinking very clearly. So labeling, making sure you label your lines, making sure you're really careful with everything so that your argument is very clear. All right, question 2 down here. This is a different standard entirely. This standard is about irrational and rational numbers. So we'll switch gears a little bit in our minds. All right, circle the numbers that are rational. So this standard has you know that numbers are either rational or irrational. And if they're not rational, they are irrational. Every number has a decimal expansion. For rational numbers, that decimal expansion will repeat eventually and convert a decimal expansion which repeats it into a rational number. So as we're looking here, square root is 6. Well, if I think about it, 2 times 2 is 4, 3 times 3 is 9. So 2 point something would be the square root of 6. That is an irrational number. So this is irrational. So if you divide an irrational number by any other number, it's still going to be irrational. Actually, it's not true. An irrational number divided by a rational number will always still be irrational. You could, for example, say the square root of 6 over the square root of 6. That equals 1. So that's just good to keep in mind. So this one is not rational. So it actually says circle. So let's not circle that. Whoops. It says circle, so we want to be careful that we're not circling something, so let's cross that one off. The square root of 25 is 5. 5 times 5 is 25. So that one is rational, so I'll circle that one. 0.8 repeating. It does say that a rational number will repeat eventually, and so 0.8 repeating, that is rational. 46.778 dot dot dot. This means we don't know what happens after that 8, so it may or may not repeat, so we have to say it is irrational. We do not know whether that repeats, so we're going to say no. Actually, if it did repeat, it would have a line above the 8, so because it doesn't, that means we're going to say irrational. Square root of 5, or sorry, pi over 5. Pi is approximately 3.14, but it is an irrational number. This number is irrational. If you divide an irrational number by 5, you still have an irrational number, so I'm going to cross that off. Negative 6.98, or negative 6 and 98 hundredths. So that one is rational. It can be written as a fraction. So that one is rational. All right, down here. Now we're going to place these rational and irrational numbers on the number line. Let's start with what I would call the easier ones. Square root of 49 is 7. Square root of 4 is 2. So that says 6 over 2, which is just 3. So we'll place those ones first. 7 is equivalent to the square root of 49. And 6 root 4 is 6 over 2, which is 3. So we're going to mark 3 and put 6 square root of 4. Now we'll get to the bit of a harder ones. These are irrational numbers, so a little harder to figure out. Square root of 25 is 5. This is a little bit smaller. Square root of 16 is 4. So it's between 4 and 5, 4 point something. Let's make an educated guess here. Square root of 25 is 5, and this is only slightly below, so it's going to be somewhere around 4.9. I'll put a squiggly equals because it's not exactly. So that's probably good enough for now. We can go a little better in a minute if we need to. We're just estimating here. Square root of 7. 2 squared is 4. It's too low. 3 squared is 9. That's too high, so it must be 2 point something. And let's see. 2 squared is 4. 3 squared is 9. It's closer to 3. And we can always check. 2.6, we'll do the work down here. 2.6 times 2.6, let's see how close we got. 36, 12, 15. This is 12. 2 times 4 is plus 1 is 5. Got pretty good, but we probably could get better. So let's try 2.8. If that's too high, we'll know 2.7 is the best estimate there. That's too big. So 2.7 would be in between these two, so that'd probably be best, 2.7. So square root of 7 is a little bit more than 2.5. Square root of 7. Last one, 3 root 2. I know the square root of 2 is about 1.41, but you could do similar estimate strategies as down here. So it's approximately, so I'll put squiggly equals, 3 times 1.4 approximately. So 3 times 1.4 is 4.2. So this is why it was important to get some pretty good estimates here, because notice that we had a 4.9 and we had a 4.2. So we have to get 4.5 would be here, so it's a little less than that. This is 3 root 2. All right, make sure you are taking notes. Go back and watch the other videos for the other sections if you need to. And don't just copy these things down, but really think about them.